In this real-life example, a customer needed to determine the time period between the rising edges of the pulse train on channel 2. His first inclination was to peak detect the waveform on channel 2 and determine the time period between the peaks. As you can see, peak detecting channel 2 simply marks the peak value of each pulse and not the leading edge. The solution here was to first calculate the derivative of channel 2. We'll enter channel 2 as the input channel and display the result on channel 3. For this example, we'll choose a smoothing factor of 7. Note the relationship of the pulse train on channel 2 and its derivative on channel 3. Since we know that the rate of change is greatest on the rising and falling edges, we can conclude that the peak of the derivative must correspond with the rising edge of the pulse. To prove this, we'll peak detect the derivative on channel 3 and mark channel 2. Through the magic of Advanced CODAS in the Windac waveform browser, we can see that the peaks of the derivative and the rising edges do in fact match up. Now, how to determine the time between the rising edges. In the old days, you might simply place a time marker at one rising edge, move the cursor to the next, and jot down the time in a notebook. In this case, 0.406 seconds. You could do this for the entire file. Seems like a lot of work. Fortunately, Advanced CODAS allows us to generate a report that includes the time between peaks. To do so, we'll select the Report Generator tab and specify channel 2 as the input channel. In this case, the output channel is ignored. We'll choose peak to peak as the cycle definition, since we're really only interested in the peaks. We'll choose time in seconds as the cycle units, and the output format will be CSV, so we can view the report in Microsoft Excel. As you can see, the peak values are reported, along with the time between peaks, in this case, rising edges. You can see here that the first time period is 0.406, as we can determine here or verify manually. Second time is 0.372. And so on. Problem solved.